Hey everybody, I am your director of IT, Tanner Valentine for AIS at Temple, and this is our first virtual workshop for technical development. We are teaching you the basics of Python. I just want to give you guys a little disclaimer about Python. I mean, this is just one workshop, so you shouldn't expect to know everything by the end of it, but we can try to guide you along, work pretty closely so you don't get concerned or scared about, I can't finish this deliverable because I don't know anything about Python. We don't expect you to, and we're going to work with you on that. Python is one of my favorite languages because I think it's very readable. It's very good for the user to actually code, not just for the actual end product. So I don't think it's as hard to sift through small syntax errors like putting colons or semicolons in the end of every statement, stuff like that that might bog down newer developers from starting to learn Python. So today, I just want to tell you guys how I think everything is going to happen, how I'm going to try to conduct all this. We're starting with the introduction now. I'm going to tell you guys about some basic information about Python, the way it's used, examples of being used within the corporate world and other businesses. And then after that, I'm going to do a quick hello world demonstration, very boilerplate, simple way to get you guys introduced with the framework. And it's something you're probably going to see in any programming class you're ever going to have. So might as well start off this with that as well. From there, I'm going to go through each of the headline important topics that I think are going to help you finish this deliverable and teach you about Python. And then with those, I'm going to have some example files that I'm going to distribute to all of you to do that alongside, or you can just run them, or you can edit them yourself. I would recommend you edit them while you're actually watching this and working along with this, so you can play around, find out more about the program that you didn't previously know, and iron out anything you weren't quite sure of. And then after all of that, I'm just going to show you guys our end deliverable, which is going to be a hangman game. And we're going to go through that, put together the missing pieces from the main deliverable, and see what we're going to end. Okay, so what is Python? It's a general purpose programming language, which means it's very versatile and can extend to many different industries. And it emphasizes readability, unlike other languages. So it gets rid of some annoying repetitive syntax things you have to keep track of, and it emphasizes readability by making everything work by indentation. So you can understand what your code is doing just by looking at it without having to sift through all the lines. It is among one of the 5 most popular programming languages used in business, mostly because it's easy and fast to debug. And so when you're using these large scalable programs for companies, you can't make the process to find issues and bugs take that long. Otherwise, that just means it's more time that their program is out of commission, which is just not acceptable to them. So that's why it's used very widely. So here's some example uses of Python in the industry. For web development, Instagram uses Python to create their web structure. So most of that app is working off Python code. In terms of data science, Spotify uses Python to control its data insights. So your Discover Weekly playlists or any of the playlists they recommend to you, the way other radios or things are created and put together is using Python. Now, natural language processing is more like being able to recognize human language. And one good use of that with Python is Google's Home Assistant. Their speech recognition software is run off Python code. And then, I mean, you guys should all know The Sims, but for video game development, the Sims 4 game runs off of Python. So it has many uses. It's from video games to industrial uses. You have it on your phone or on your computer 100%. So Python is very expansive, used very widely. So first, I'm going to show you guys a quick hello world demonstration. I urge you to please follow along. Let me just bring up the console. from your idle text editor. Now, if you're here, you can either click on File and click New File. I just usually do Control N because it's faster. And this is just what you're going to do every time you start a new program or open up one. Now, I'm going to introduce you first to the statement we're going to be using most of today. You should get really comfortable with the print statement. It's just going to put a line of text into the console and you run the code. So you're just going to write print, your parentheses, and then I'll explain this to you in a future slide why we have to do this, but put down either double quotes or single quotes and just write hello world. Now, this is just demonstration. It doesn't matter if you write hello world. I just wanted to get you guys used to the print statement. So from here, you're going to save this because you can't run it without saving. It's all saved. And now just hit F5 or run, but yeah, F5 is a shortcut. And it's right into directly in the console, hello world. So this is our primary way of getting information from our code to be printed out into the console right here. So this means we're going to be using this in our end deliverable and all of our exercises. So you can show how things are calculated, how certain methods or functions alter text, alter numbers, alter the variables, and we can see how they're the end product by printing them out in here. Now, you can change this all you want. One thing I will urge you guys to do is remember that you're not playing with loaded firearms. Please mess around with things. Please try new ideas. I can just put my name here if I want, make it a little more personable. Just save it and run it again, and then it says hello Tanner. So obviously it's a very small part of the language itself, but it's a very, very important building block to get used to the print statement. You can use it in all of our work today, and in the future, for more difficult projects, you'd use it to debug your code, find out issues with it, make sure things are working. It's very, very important, very foundational statement to get used to. All right, so let's begin. The first thing I want to talk about are variables. So whenever you're programming in any language, the thing you're working with most is information and values. Maybe you get them from a list, user input, some type of data sheet. You're trying to do something with that and turn it into something else. So what we use to hold data values is variables. They can hold a bunch of different things, numbers, sentences, lists of things. And in Python, in other languages, you need to create them first, then you can assign value to them. In Python, they're only created when you assign value to them. And you do that with the equals button. That operator, it's the assignment operator. It makes that whatever's on the right of the equation be the value of the thing on the left. See right here, right below, and it says cat type equals, in parentheses, quotation marks, calico. That means the variable cat type was created and is equal to the string calico. I'll get more into strings later in other data types. One thing to be very cognizant of is you're making variables so you can use them as the programmer. That means you can name them whatever you want, but you should follow certain guidelines, not just to help whoever else is looking at it to understand what's happening, but to help yourself look at it. Use descriptive names, because you can always spend a little more time writing a name, but if you have to come back and all of your variables are X, Y, and Z, maybe you don't know what you're doing when you left off. But they are case sensitive, so keep that in mind. What you should try to do is write them in camel case, which is where you do the first word, no spaces, and then the second word that you're using to name the variable, you capitalize that, and then every word after that, you just capitalize the next letter except for the very first word. So I wrote student name here equals Tanner. Student, the S is not capitalized, but the N is. And that would just carry on if I had like 3 words like student name, year. the Y and year would be capitalized. And then if you do print student name, it would output the value of the variable, not the variable itself. So because the value of student name is Tanner, it would print out Tanner in the console. That works the same way for if I did student year or student weight. And now I'm going to bring up one of the exercises that I've created for you guys to look at as well. All right. Now, if you look at this, these three variables, name, age, and school year, I start by assigning them. Name equals Tanner, age is 21, and school year is I'm a junior. Don't really pay attention to the quotation marks right now. I've kept everything the same data type just to eliminate that confusion. And say if I were to run this right now, you can see the thing it eventually prints out. But I first want to show you that if I write name, so let's see what it is. It's Tanner. Oh, I need to bring this over. You can see in the console that if I write name, because I want to see what it is, it says Tanner, just like it says in here, because that just ran. If I write age, the variable name, I want to see it is, it's 21. Same if I write school year. If I write something that I did not declare, let's see, orange is not defined because you never defined the variable. Now, if we look at what I originally wrote in here, just another use of the print statement. You can see I didn't write, well, in here it says my name is Tanner, I'm 21, I'm a junior. I only wrote, hi, my name is name, I am age, and I'm in this school year. I didn't actually write these. What you can do is in these print statements, if you have a string, after you can close the quotation marks, use the plus symbol, the concatenation symbol when you're printing things to attach this value of this variable right here in the sentence. So it'll work out, you see I have to put like spaces after as if, because that's not actually stored within here. But then it prints out the entire thing. So next is data types. We're working with all this information, but the way in which these things are recorded are different and they function in different ways. The first one that you're going to see the most, probably, we're going to work with a lot today, is strings. Strings is any like sentence, group of text, anything that you really want to write in like normal actual English. You surround these with either single or double quotes. For example, if you were, talking to a user through the console or something, you could write hello user with the quotation marks around the sentence. And if you print that, then it'll print the phrase hello user to the console. Integers are the first kind of number. They are only whole numbers. They can be positive or negative, but they have no decimal points. If you have decimal points, then you're working with floating point numbers. Floating point numbers are anything positive or negative that is either full numbers, but it'll be like 1.0, 2.0, or it's anything with decimals in between. Essentially, if there's ever a decimal point, just know it's a floating number. Now, we're not going to get really in depth into things beyond this, but we are going to work with lists once in the end deliverable. So listen tuples are collections of other types of data. You can have a list that's full of strings, a list that's full of numbers, a list that's full of a different amount of them. But one thing to keep in mind is if you've worked with lists, the index of them begins at 0. So if there are 4 items, if you want to access the first item, you have to use that list name in 0 up until the list name in 3, because the third one, or the number 3, would actually be the 4th item in the list. Now I'm going to bring up exercise with that. Put this over here for you guys. Right here. So these are examples. You can see I wrote these examples in camel case. So string x as in string example, int x as an integer example. This is, I just wrote pumpkin. Make sure you put the quotes there, either double or single. I just prefer double. You can see the integer does not require those, but it cannot have any decimal points. And then the floating number has decimal points. I also created a list of a bunch of different numbers just so you guys can see what they, they're structured like. They use these brackets instead of parentheses. So just keep that in mind. Now, you can see I have print statements for all of these. I have print statements for each of these, so they print out the value, but I also wanted to print out the type. So I know I had the name, string, integer, and floating point, but you can see that you can check the type of anything by putting type and then whatever you want to check within the parentheses. Now I'm just going to run this. The console over here, you can see that it printed out pumpkin class string because it prints out the pumpkin first. What to tell you what kind of data it was. Then the work goes down the line, 57 class int, 34.6 class float. When it prints out the list, it does use the brackets, so it shows you the entire composition. But then it shows class list. If you check that, I wanted to, like I mentioned, strings, not strings, lists, they index at 0. So I wanted to check the type of the first list item, Kentucky, right? Print the type of list and then see brackets 0. You just put that next to the word list, just free floating like that. And then that will be accessing Kentucky. So I checked the type of that and then printed that out. All right. Certain data types cannot be used in the ways that other data types can. So sometimes you have to cast one to make sure that the variable you're creating is a certain type of data type. You can't do this from like your sentences to cast them into numbers, but if you have a number, you can cast it into like a string format or a different number format. A good example of this is if you wanted x to be the string version of 3, you would write x equals str parentheses 3. And then for integers and floating point numbers, be int and float. This makes it print on the console differently, makes it so you can use them differently because you can't print integers and floating point numbers into the console when you connect them or concatenate them to other strings. You have to do that only working with strings. So you have to turn all your numbers into strings first. I can show you guys a example of that. Please, I really do emphasize you guys work alongside with these exercise files, maybe edit them, test something out. So originally, when I created this variable x, I made it just the number 3. It's an integer because there's no decimal point and there's no quotation marks, so it can't be a string. Now, if I were to print it out like this, print str of x, then it would print out 3, but need quotations. If I were to do it here, it would work just as normal because it started as an integer. And with here, it prints 3.0. It's the floating point now. Let me run that to show you guys. You can see right in the console. 3 doesn't show the quotation marks because it's supposed to just be writing text, but it is a string. And then 3 again for integer, and then 3 for the float. So this is just a little trick because we'll probably have to use it at least once in our deliverable, and sometimes issues with data type can be what bog down or trip up new developers. So operators are used to perform operations, as you'd imagine, on variables and values. Addition uses the plus symbol, but things to know is when you're working with strings, if you would add 2 strings together, it would concatenate them, which means, say if I had a string that says, hello, my name is, in quotes, and then plus, another one in quotes, Tanner, it would concatenate them to make one string that says, hello, my name's Tanner. Now with that, you have to make sure you add in the appropriate spacing because sometimes you might have one variable or another string and they just kind of smush together because you didn't put a space in between. But that's something you can easily find out when you're working with it. Subtraction works the same as you expect with numbers. Can't really use it on strings because you can't subtract letters from a sentence. Multiplication is the asterisk. Division is the slash, and then we get down to a few strange ones. The modulus operator works with the remainder when you're dividing things. Say you're dividing 3 into 14. It goes into 14 4 times to get to 12 first. And then there's 2 more between 12 and 14 that does not evenly divide. The modulus product of that equation would just be 2 because the remainder is 2. That's the last that's left over that you can't be evenly divide into what you're trying to. I'm going to skip over exponentiation for a second. The opposite of modulus usually is floor division, which essentially when you are dividing, say like 14 by 3, it just tells you, it rounds down the division down to the nearest whole number. So the 3 went into 12 4 times, so the answer would be 4 instead of 4.6666 because of that last 2 that's left over. And exponentiation, that's just 2 to the power of 4 or 3 to the power of 5 or something. Anything you're using exponents, you write 3 asterisk asterisk 5 or whatever numbers you're using. Now let me pull up the exercise for you guys. It's a little lengthier, but I put comments in between for you guys. I just made the same exact examples that I was just talking about. X equals 14, y equals 3, these variables to work with. You can see I did just a basic addition, subtraction, all the operators at least once. But I want to show you guys that you don't have to do these operations with just two different variables or two different values. You can change one variable by itself. Say you had variable x is 14 and you want to make it 19 instead. You could write x equals x plus 5. So it's just essentially reassigning using this assignment operator, but you're using this other operators to change the values. Or you can do shortcut of this kind of format. If you want to add 6 to y to make it equals 9, you just do y plus equals 6. It's just a little shorthand, but it's not necessary if it confuses you. Now let me just run these for you guys. From side by side. You can see all the operations check out. X plus y equals 17, 11, 42. There's the normal division. Here's the modulus because there's 2 left over from the 12 and the 14. Just exponentiation. And here is the floor division, since 3 times 4 equals 12. There's 2 remainder, but it goes evenly in 4 times. And next, as an aside, I did want to mention comments because I had them written in some of the exercises and the deliverable. To add comments to code, you just put the hashtag or pound sign or number symbol first, and then write your comment after that. They have no actual impact on the code itself. It's just help, write down notes for yourself, maybe to help you resume a project that you had to do, you started like a week ago. Or maybe you're trying to help someone else read your code to teach them about something. You'll have comments saying what's going to happen, what they're trying to do, explaining the process throughout the code. You can also use this. I've used it many times for this. Say you're not sure if one piece of code is breaking what you're trying to do. You can just comment out that line, and then you're essentially temporarily disabling that line of code. So you don't have to delete it all and then remember it and then try to retype it. You can just essentially disable it for a second and then just get rid of the hashtag key to essentially resume it. I'm going to bring back up my operators exercise that I just shared with you. You can see I have these comments right here. Trying to explain something that's happening, to explain how the operators are working. I also have another exercise right here just for this, but it's not huge. Essentially, I wanted to show you more of the disabling part of this. You can see I have 2 print statements. This one says, hey, this line of code is active. This one says, hey, this line of code is inactive. They can see this is all red with the style of font and color that I have. But that's red because of this number key right here. If I get rid of this, then hey, it's active again. The colors change, looks just like the other one. But if I run this, you can see in the console, only one of the lines print. Hey, this line of code is active, because that one does not have the comment symbol in front of it. All right, so next up we have functions. Functions are essentially a block of code that you give a name to, and you can run it as many times as you want. This is to help you avoid redundancies and to write repeated code. Maybe you have to write a greeting for a bunch of people, but instead of writing out the full greeting with their names changed every time, you could make a function to just auto print those with those people's names in it. Usually you only need one if you need to use like a line of code or something multiple times within a program, but it can also just help with your own readability. So with functions, first you have to define them, and you can see right here, you start with a def and then whatever you want your function name to be. I put just a filler name, and make sure you do it in camel case just for readability. Then you have two parentheses, a colon, and then all the lines afterward have to be indented. The lines afterward are the ones that will be run when you call your function. It's essentially the main meat of the function that you're actually trying to write, the tasks you're trying to do. After you write this, all the lines after, if they're not indented, then they won't be included in the function. Thing with Python that we have to reiterate over and over again. It's because we don't have like colons or anything or semicolons at the end of statements or functions. We have to keep in mind our indentation. So, but after you define a function, the way you have to use them is by calling them. But that's pretty easy because you can just use the name of the function. You just write your function name, whatever you actually named it, and the parentheses, and then that's the whole command. You just write that. It's a full line of code. It calls the function. It does that action. So before I get into the exercise, I'm also just going to briefly mention parameters because I'm going to have them in the exercise. So parameters, they're the information you can pass to a function. Not all functions need to have parameters, but a lot of them do. And so you can alter code based on the information you're giving it. The way to do that, to define functions parameters, is the same way you do normally, except inside those two parentheses for the colon, you put your parameter. Parameters are essentially function specific variables. You create them up here inside the parentheses, and then throughout your code of the function, you use those same variables. And when you call your function, just by writing this out, and then whatever information you're passing, that'll be used in place of the parameter name throughout the function. Now, let me pull up the exercise for you guys. So you can see we start without functions, and I want to print some greetings for some new students. And see, I had to write the hey, my name is, and then their names are different, and I'm blank years old. It's pretty simple, but I had to write it 3 times, which I don't want to do if I can avoid it. So when you do use functions, I'm going to call it greet code just because I'm trying to write a greeting, try to make it descriptive. I start to define greet code, and because I'm using 2 parameters, use a comma to separate them. The first one is name, because I'm going to use the student's name and their age right here. So I do that, put those in parentheses, put the colon, all the code after is going to be indented. So I'm just doing a print statement, basically the same script that I wrote up here, except I wrote, hey, my name is space, and then use the concatenation to combine strings. And it equals plus name, and then plus, and I'm the string version of age, so you can actually print it because it's a number, blank years old. So while it looks strange now, if I call these down here, Tanner will be subbed in for name in this spot right here, and 21 will be subbed in for age. So I can write right now for you guys. You can see I also have different names down here, different ages. And see these ones, let me bring this over for you. See, these ones are with the functions. They're all the same except for the name and the year. There's no mistakes or anything. These ones up here, I didn't use functions. I had to repeat my code over and over again. And you can see it makes it very easy for small mistakes, even just syntax or spelling errors like these, to come up because you have to keep typing the same thing. You're more likely to mess it up when you can instead just use the function, reduce the amount of lines of code you actually have to write, which will let you be more precise. So next I wanted to tell you guys about conditional statements. So if statements, they are a set of code that checks for a logical condition. And if that's true, then the code within is executed. But first I want to talk to you guys a little bit just about conditional logic. We use just, a few examples of these in Python are equals, not equals, less than equal to, greater than equal to. Very simple stuff you've seen in math. I'm going to bring this over here just to show you guys. So if you run this, you see A is 14, B is 12. The basic condition things like A is less than 12, A is less than B, A is more than B. So some of these should be true, some of these should be false. And also, I just wanted to show you guys this nice little feature that we're probably going to use in our deliverable, where if you have like a list and see apple, banana, pear, they're all within it. This is a version of a conditional. You're asking the code to find out if the string celery is in the list fruits, and it's not. So this will print false. Banana is, so this will print true. Now we get the console over here. You can see that these answers line up with these pretty accurately. So A is not less than B, so it's false, and it goes down the line, checks if all these are true or false, and it spits out the answer. If an if statement has these statements within it, it will only run if these are true. So a statement will only run if this is true for this one, but any of the ones where it says false, the code within will not be executed. So kind of like functions, formatting if statements relies on indentation. That means you write your initial if, and then your conditions here is B is greater than A, and then with the colon to separate it, and then all the stuff after indented is within the if statement. So this statement is essentially saying if B is greater than A, print the phrase B is greater than A. This first statement is checked, and only if this is true will this statement run. So let me take out a basic one for you guys. See in this one, once again, A is 14, B is 12. It says if B is greater than A, it's going to print B is greater than A. And if the opposite is true, it's going to print that. And we see that A is greater than B already. So only this one should run. A is greater than B. And let's see how that works. Okay, save. And not too surprisingly, in the console says A is greater than B. So follow along with this. Before we move on to else ifs, everything else, I want to talk to you guys that show you guys that you can have multiple conditions within an if statement. You can use either ors or ands. So if you use an and, that means both statements that you write are going to have to be true for the if statement to run. If you use or, only one of them has to run, or has to be true for the entire code to run. So I'm just gonna like this. Usually I will put the ands and ors in parentheses just to make everything readable and easier for you to understand how your own code is working. So I'll say if A is greater than B and A does not equal B, print, and I'm just going to make it simple on myself, just write hello world, so you can tell it apart from the other statements. So I'm actually going to make that false. This one can't be true because they're different. But I'm going to show you guys an or statement with the same conditions, so you can see that it will still run. Except I will call it goodbye world. right, and you can see in the console, only goodbye world is printed. That's because A is greater than B, but A is not equal to B. So this one cannot print because A does not equal to B. Both of them aren't correct. So it cannot print this. But well, this statement still isn't correct in the or if statement. This one is, and you only need one for this code to run. So goodbye world is still printed. So now we're moving on to a little bit more complex conditionals. These are if-else statements. If-else statements give your if statements a little more versatility. So if the initial condition is false, not true, the else statement will run rather than the original if statement. So you can see in this example here, if B is greater than or equal to A, we'll print that statement out. But if it's not, we'll say B is less than A because that's the only other option, and that's what you put there. So it initially checks the first statement, and if that condition is not correct, it will go to the else statement. But if it is correct, it will still stick with the original if statement. It will not run the else. It's they're mutually exclusive. Now, before we go into exercises, I also want to mention else ifs. These give you, the chance to put even more than two options. So in this one, you can see is if B is greater than A, it'll print that. But instead of just going straight to the else statement, we have an elif. Elif is short for else if, just lets you write this a little faster. And now we have three options for what to print with our if statement. So if B is greater than A, it will print that. Else, if B is equal to A, then we'll print that. And then finally, because there's no other option, just write else B is less than A, because if it's not equal to, it's not greater, it has to be less than. Now, with these statements, you don't just have to have one else if, you don't have to have any else ifs. You can have as many as you want. You have to make sure that your individual conditions do not fight with each other. They don't make your code make no sense, because the longer you make certain if statements, the more complex they can be. Now, I'm going to show you guys some of these complex conditionals, really only one, but you'll see them within our deliverable. Once again, kept A equal to 14 and B equal to 12. It's essentially the same thing I wrote in the PowerPoint. Now, we see that A is greater than B, so it cannot run this statement because B is not greater than A. Then once again, B is not equal to A. They're two different numbers, so it cannot run this statement. It has to run the else. So we're going to expect, say it says B is less than A in the console. And as we'd expect, it says that right here. All right, guys. So next, I wanted to talk about loops, or more formally known as just iteration. Loops, kind of like functions, are used to rerun certain sections of code repeatedly, or to iterate through data structures, maybe like a list or a tuple. The difference between them is, for a function, for every time for it to run, you have to call that statement. While with a loop, you set up your initial loop and it will just run until the condition is no longer true. You can have functions inside of loops. You can have loops within loops. It makes things a lot easier for large scale projects. So there are two main types of loops. One, the third one, but it's essentially the second one. The first one is while loop, which is essentially you have a condition, and while that is true, the loop will continue to run and execute the code within. For loops, they are used to set a certain number of times for a loop to run. So you just want to run it exactly 5 times and not be dependent on the condition. You can set it up just like that. And then a little brother of that essentially is for each loops, which are used to iterate through lists or dictionaries or data structures, usually. All right, so like I said before, while loops run while a condition is true. Say you set the variable I, doesn't have to be I, it's just anything, was equal to 1, and you have this while loop while I is less than 6. You can print out I and then set it to 1 greater than itself, which is how you use the plus equals 1 operator. So this would essentially run 6 times or 5 times, starting at 1, and then once this runs 5, and the 5th time it will become 6, and then this condition will no longer be true, so it cannot run. All right, so before we get into the exercise file for this, I want to show you guys a little bit about break statements. Break statements, they're not a huge aspect, but they're used to stop a loop even if the condition is still true. Maybe you want to force something halfway through rather than it finishing completely. This is as simple as putting like if statement inside like the last while loop you saw, where if I equals 3, then just break, which means it will no longer print the 4 and the 5 and get up to 6, because once it hit 3, the loop stopped. Now, let me pull over the exercise file for this. Now we have 2 different versions of this. This one is break statements. So while it goes to 10, it will stop at 5 with this break statement. And this version starts at 0 and will print until it goes to 10. Now, pulling over the console, you can see that the first set, the first while loop with no break statement, it goes 0 through 9. It starts at 0, goes to 9, and then on the last loop where it becomes 10, it stops running this one. But conversely, with the break statement, it checked in the 5th loop if the number is equal to 5, and it was, so it broke the loop completely, stopped there, did not get all the way to 9. All right, coming on to for loops. They are used to iterate a set number of times. And what you need to keep in mind for loops is that the loop variable that you use increments by 1 automatically at the end of each loop. So in this first example here, it says for I in range 6, you don't need to use the letter I as your loop variable. You can, it's usually common practice to use the letter I. You put your repeated code after the indentation, after the colon, like you do with just with functions. Then this example would run 6 times. Keep in mind that essentially what the loop variable does is it starts at the number 0 and then moves up, adds itself by 1 until it reaches the number 6 in this first example. But you can change the formatting to include a starting range. So in this one, it says for I in range 2, 6. So in this situation, I is assigned to the start, runs through until it hits 6. And then it will not run that time. Also, I'll show you guys in the exercise files, but you can add a third argument with another comma and then a number to change the step, which means instead of I or whatever loop variable you're using, adding itself by 1 at the end of each loop, you could have it add up by 5, by 10, by 20, anything you want. And one thing to keep in mind is that the start of the range, like 2 here, is inclusive, which means I will start at 2, but the end of the range is exclusive, which means once I become 6, it will not run. So if you have like print statements on the inside that just print out what number like I is at the moment, it will only go 2, 3, 4, 5. Now let me pull up the exercise files for you guys. You can see I changed the loop variable. So it says for X in range 20, which means it's going to start at 0 and run 20 times. I have the string version of X using data casting. So in this loop, I'm just going to print out I've in whatever X is at the moment shipped so far today. Now you don't need to interact with the loop variable. I just think it's a really helpful tool. I do it often. You could have something completely tangential to this letter X, but it's usually helpful with for loops to be able to have something iterate or increase and then work off that. Now in this next example, it starts at 10, moves up to 30, which means I just increased the or decreased the range, I should actually say. So it starts at 10, moves up to 30, 30 is not included. And then the last example, I have it, so the step was increased to 25 with this third argument right here, which means X will, instead of starting at 0, we're starting at 10 and then adding by 1 at the end of each loop. It will add by 25 at the end of each loop. You can see I also made the end range 151 because I wanted the number 152 to be included. Now I'm just going to run this. And we have a lot of stuff in this console because I looped a bunch of sentences. But you can see that this number of chips you've eaten so far today increases by 1 and loops through until you hit 19. And the miles you ran at the park starts at 10, keeps running and running and running until you hit 29, because these ranges were not inclusive at the end. Now, a little bit differently, you can see with the step change, instead of adding by 1, goes 0, 25, 50, 75. And then it does include that last 150 because I made the range 150, 0 to 151, and then 0 to 150. All right, so the last loop type, which is essentially a little brother of for loops, is for each loops. These are used to iterate over a sequence of items or a data structure. This could be the characters in a string, or like in the sentence you wrote. It could be the items in a list or the keys and values in a dictionary. You can see this example I wrote, fruits equals apple, banana, orange. If you write 4x in fruits, once again, this does not need to be the letter X. You can have this variable be anything you want. And then I'll say print X. Now, I didn't understand this when I first learned Python because I didn't set X to anything, but Python is a little smarter than some other languages, which means it understands that fruits is a list and you're probably trying to iterate through it somehow. So essentially, when you write this for blank in fruits, or in this case for X in fruits, when it iterates through, X begins as apple, and then it iterates through and becomes banana, it becomes orange. So if you write 4x in fruits, print X, you're printing apple, banana, orange, rather than the letter or the number 0 and then to a certain number. Now you can keep in mind, because this is really helpful for your own sanity and writing style when you're trying to iterate through certain lists or anything, you probably should not just use the letter X for a loop variable in the scenario. I'm going to show you another example in the exercise files, which should usually be pretty helpful. So bring this over here. I have some capitals, some state capitals written up here: Harrisburg, Richmond, Juneau, Dover, Albany. And I want to show two versions of essentially the same for each loop. Now, this first one I wrote for capital in capitals. Now, capitals is this list we're working with here, and capital is the loop variable, which means each time this loop runs through, capital essentially takes the place of Harrisburg, then Richmond, then Juneau, then Dover, then Albany. So you print this out, it's going to print all of these in order. Now, I want to show you that you guys be very cognizant of your loop variable in for each loops. You can be anything you want. They still act the same, but you should try to create one that you can understand, that people who read your code understand. So I did the same exact loop, except this time the loop variable is house, but it should print out the exact same thing because the same values are being assigned to it throughout the loop. So let's run this. And if I pull this over, you can see the same set of capitals were printed in the same exact way. The loop variable you choose does not matter except for your own readability and understanding. So I would emphasize that you do try to do something that is a little more descriptive rather than just one variable. But if it's a small project, maybe you don't need to. It's up to you completely. All right, this next slide is not nearly as important as the others, but we're going to use it at least once in the final deliverable. Modules are essentially tiny libraries that are not included initially when you install Python. A lot of statements, a lot of commands come with Python when you originally install it, but some are seen as not as important, so they're not included to start. And what these do is they give you commands and statements that you can't normally use. But to use them, you initially have to import them. Usually at the top of your code or an intent project, you'll see people write import, such and such, or whatever module they're using. We're going to be using the time module at least once or twice in the deliverable. So you just write at the top, import time. Now, what you have to keep in mind is when you use the statements from these modules, you have to use the package name first and then the name of the function. So you see right here, instead of just writing sleep 0.5, which makes the code wait for half a second, you have to write time.sleep. So it knows that you're going to that package, then using that statement. And finally, with our presentation, I'm going to go over methods. Methods are, another smaller section. They're essentially functions that belong to an object, like a string or number or a variable. And just a good example of this is changing the case of a message. So if you get user input, which you use by doing the input and then parentheses command, what's in the parentheses right here is just the message that's displayed in the console for the user to answer. So normally you just write message or whatever variable you want to use here equals input and then your question. And then that, their response is stored into the message variable. But what if someone responded to like, what's your name? And they messed up all, like maybe they have like the last letters lowercase or something, and it can mess up your entire data, your data set that you're trying to use. If you want to make things all the same, you can make it so they're all become like lowercase. You can do this by, like message equals input, but at the end of this, you write dot lower, and then with parentheses. You can also have it, have this initial command, and then in the next statement, write message equals message dot lower. You don't need to do these all at once, but I actually like to because it makes things work in my head a little bit more easier. Now I have a quick little exercise file for this. And I wanted to show you guys also to get user input here. So I just wrote username because this is what I'm going to have the user put as their name, based on this question. So they can be asked, what's your name? They're going to input it, and no matter how they do, I'm going to print 3 different times. The first time all lowercase, first time, second time in all uppercase, and the third time with the first letter capitalized. You can see that you have to have these little parentheses at the end of the methods right here, even though you're already within the parentheses of the print statement. But that's not a huge issue. Now, if you run it, first of all, the console asks, what's your name? So I'm going to respond, but I'm going to act like I never learned how to read. And it's going to mess it all up. But you see, first one's printed out all lowercase, then uppercase, then correctly. So methods like this, especially the upper lowercase and capitals, there's a bunch more than those ones. These are the ones that I've used most frequently because they're really good, trapping any errors if you want a user to respond to a certain question, but they throw in some weird capitals and then your code can't read it. We're actually going to use this one time within our final deliverable. So I think it's very helpful. All right. With that being said, we are going to second move on to the final deliverable. I have a template for you guys to fill out. I'm going to go through it with you, so you don't have to be concerned about trying to do commands that you don't understand or that you didn't think you'd have to do. This is going to be the guided experience. I just want you guys to understand how to use Python and try to appreciate it like me. All right, so let's get into it. All right, so to start off, I wanted to just show you guys, how the end product is going to work. We're doing a simple hangman game. I'm just going to run it for you guys. Bring this over here. Or first, the program will ask you what your name is. It's going to put Tanner. And now, we get a secret word. We don't know what it is. And we have to just guess a character. So I'm going to put the letter A because I'm not sure. This is wrong. I have 10 guesses, apparently. So let's try some more vowels. We got that set up now. And I'm going to spoil this because I already know what the word is set to. It is a secret. And by finishing the letter, we win. But try to do this again and guess the wrong thing 10 times. That would tell me that I am incorrect. So I have 0 more guesses and that we lose. Okay. So with that being done, move this to the side and bring over the template that you guys are going to be working with. Now I have a bunch of comments in here to try to make things, a little more understanding for you. You also don't get tripped up with something that you didn't expect, or kind of, more guided experience. So to begin with, you can see here, that we use these methods from the time module. So first we have to start with importing time. Just like that, it's done. Then we have to define our original function. And we know how that goes. So defining, start with def. Then I'm just going to name it because this is going to be the function that encompasses the entire game. So I'm just going to name it hangman. So it's easy for me to understand. Now, I want to have this game be easy for us to change the word, the secret word, the guess. So I'm going to put game word as a parameter. And then, because I'm a word, which is going to be the actual word we have to guess, set equals the parameter, I'm showing word equals game word right here. Go down a little bit lower, and we can have, if you guys want to have the game harder, we can have less turns. I'm going to still have 10 turns, which is the amount of times you get to guess in a row without the game ending. Okay, so we need to have this game keep giving you new turns until either the game is over because you lost or because you won. So we need to have a while loop that will run until the turns are gone, because either it breaks when we win or it runs until turns are 0 and then we lose. So I'm just going to start by putting this. Oh, make sure, because we're in this function, everything has to be at least indented to like right here. So we're going to start with while turns is greater than 0. This just ensures that all the code after this will keep running until the turns are over or until this break statement, which is when you win. Okay, so what this game does by to check your answers, it has a string right here called guesses. Whenever you guess a letter, it's added to this string. So if you guessed A, B, D, X, it would become, guesses would be A, B, D, X by that time. And what this game does to check if you failed or you succeeded is it will use for each loops here to check all the characters and guess, and if they're within the secret word that you set, then it'll print that letter, and if not, it will print a dash when it will increase the fail counter by 1 for each missed letter. And that means if there's any fail counters, if there's any, if that's above 0, then you used a turn and you did not succeed. So to start with that, we need to originally set the failed to 0, because otherwise you determine your turn would never end, because it would think that there's always something missing and then you can never win. So after making the fail counter, we have to iterate through the secret word that we set to check for each letter if that letter is within our guesses. So I'm just going to write for car as in short for character in word, and you have to have it right word, because word is the variable we set right here. And then from there, we add through each letter, because with this loop, it will temporarily be each character in the word. So if I set the word secret, it will start off by iterating with car be equal to S. And then this will run the entire code for the letter S, and then for the letter E, and then C, and then so on and so forth. So for each character in the secret word, you have to first check if that character is in your guesses. If it is, then we'll print that character that you set. Notice that these variables are the same as this loop variable. Because of the scope of variables, these will not impact each other. But if you had this, indented leftward, and they were just separate, it might impact each other. So in this if statement, you can see, if this is in guesses, then it'll print out this. But there's also an else, because you might not guess the letter right. And if that's the case, it will print just the dash and increase the failed counter by 1. Which will keep your turns, moving forward. Right. So like I said earlier, if there are no failed letters within these guesses, that means you guessed all the letters correctly, which means that you won. So we have to add a chance for that to happen. Right. Failed equals symbol, not the assignment operator. You need the 2 of the equals buttons. If that happens, then you're going to print into the console. Just you won, total player with what happened. And then you're going to break the script, because otherwise this would keep running because you haven't used all your turns because you won. So you need to have the script break. So in the event that you win, the loop will stop rather than continuously moving and moving and moving, even if you guess all the letters. All right, now we have to actually have a way to get the user's input and get their guess. Now, I told you guys about methods before because I don't want someone to accidentally put in uppercase letters and it messes up how the word looks at the end, messes up the the game's logic. So I'm just gonna put guess. That's a Q. Guess equals input. Guess a character. And you see I have this colon here. It doesn't actually affect anything. It's just part of the string because that's how I want it to print in the console. But make sure you put lower, because this will make sure that all the letters you guess are lowercase and will show up in the Hangman game the same way. Okay, so this next part is at the very end of this while loop at the top. You can see we're still at this indentation point, which means we're still within this original while loop. We need to have a way for the turns to actually change. So you can see this is here and these things are happening, but these are indent over, which means that we need to put in an if statement. So I'm going to say if guess is not in word, which is the secret game word variable that we use at the top of the function, which means if the guess you just made, that letter, it's not in that string, if it's not one of the letters in there, it will decrease the turns by 1, print that you're wrong, and then tell you how many turns you have left. And right down here is one more if statement. It's essentially, if it is your last turn and now turns equals 0, it also tells you you lost. So essentially, within this whole while loop, we start with creating the fail counter. We checked all of the letters and everything to see if it's printed out correctly, and because it puts that first in the console, and then asks you to put in your input. And if your guess is not correct, it's not in the word, decrease your turns. But if it was correct, it will go into the next loop, and then check if you will print out all the letters, print out the progress in the game so far, and find out if you won. Now, this is all nice and good, but we have set up this big old function with a bunch of loops inside, but we don't actually have a way for this to run. We need to call the original Hangman function that we set up. I just have it set as Hangman. So all you have to do for that is write Hangman at the bottom, and then whatever you want your secret word to be. Just remember that, see, I put this parameter here so we could change it to anything we want. So this is game word right now, but let's make it pumpkin. I'm going to move over to the finished product to show you guys that, so I can still save the template for you, but let's make it pumpkin. Now bring over the console, asks our name again. I'm going to go with Fred this time. And you can see the word is longer and it's different. So we already know the word because we said it, but let's see, oh, look, it actually has changed from secret to pumpkin. the end it says you won. Now, if we do this again, just to reiterate what happens when you fail, let's just put in the letter G because it's wrong. You can see that it does this whole, starts guessing display first of the letters, and then it will say you're wrong after, and then your guesses. And then this is the start of the loop, this guess a character part. Because this happens first in the while loop, all the guessing and the printout of the progress so far, and afterwards actually takes in your guess. All right, now just showcase the losing again. It's just like that. With that being said, that is the end of our Hangman deliverable and the end of the first technical development workshop within the 2021 to 2022 school year of AIS. I wanted this to be a little easier for you guys because I want to have more Python projects coming forward. I want you guys to get used to this language or used to coding in general if you haven't before. But we have tons of classes within MIS that can help that too. I really hope you guys enjoyed this. And if you have any questions at all, any feedback, please come to my office hours. I will be happy to help you through this, through other issues you're having, and maybe just an installation problem or something. I really want to make this as easy, accessible, and interesting for you guys. So please reach out to me. I don't bite, I promise. But with that all being said, thank you so much all for coming to this. I really appreciate it. And I hope you come to more of these. All right. Bye-bye.